Okay, so starting with example 5, we have a little bit of a different picture. You can see now that we do not have a similarity statement. Okay, what we have is talking about the triangle proportionality theorem. And what that says is that if a line parallel to one of the sides of a triangle intersects the other two sides of the triangle, then the line divides these two sides proportionally. All right. So the big deal is that it needs to be parallel. And if it is parallel, then when it divides these other two sides, it'll divide it proportionally on both sides. Okay. Now, what that also means is that we have a shared angle. All right. So what you can see is that we end up having a little triangle and a big triangle. And if we were to pull these triangles apart, it would look like a bigger triangle and then a little guy like this. Okay? So here's the little one and here's the bigger one. Now these are not exact. Okay, but if we were to label those sides, let's put that S here and the S here. Those are matching. Then our T would be on our little guy. T would go here. Our P is on the big triangle there. Okay. Then we're going to cut over to Q. Q's on the big triangle. And then up here to B, which is on the little triangle. Okay. So you can see that S is that shared angle, which is going to be equal. And then we've got proportional sides. And so by the side angle side theory, if two sides are proportional, okay, and we know they are because they're parallel, and there's a shared angle in between, okay, then those two are similar, okay, those two triangles, all right? And then we can solve for a missing part of that, just like we do when we have two triangles. And I've drawn them separately so that you can kind of visualize what I'm talking about. So triangle S is our shared angle, and here's that small side here, that's our X, okay? The big side for our big triangle ends up being 15 plus X, okay? Plus X. Don't forget to add those, okay? It's split them, but we have to add them to make a big triangle, okay? So we can also just say that X over 15 is proportional to 3 over 9. Okay? These chunks are proportional as well because it divides the two sides proportionally. So the small side over the big side is going to be the same proportion as the small side over the big side. All right? And sometimes that's just the easy way to go about it. So our purple sides, those are those in between sides we have measurements for, okay? And then over here, our green sides have been divided proportionally. So I'm going to set my small piece on this side over my big piece, X over 15 equals the same proportion as the little side over the big side over here. So 3 over 9, okay? Once again, we're going to cross multiply. So we'll have 9 times X equals 3 times 15. And 3 times 15 is 45. Okay, we want to get that X by itself, so we're going to divide both sides by 9. Okay, and then 9 up, 9 down is going to cancel to 1, and we'll have X, or that little side, equals 45 divided by 9, or 5. So the value of X equals 5. Okay? And that's how you'd solve that. Let's go ahead and look at example 6. Now, once again, we have parallel lines that have divided our triangle. And remember what we're going to do. We're going to go small side. It's going to divide these two sides proportionally. So our small sides over our large sides will equal the small side over the large side of the other side. Okay, because that's what it means when they're proportional. The only problem is here what we are given is we have a small side here, the small piece that was divided, but we don't have our big piece alone. We just have the full thing. So we know that this piece is going to be 12 minus that 2. So that's going to be 10. Okay, so keep an eye out for that. This 12 is not going to be this divided piece. It's going to be the whole thing. So we're going to have to subtract. Okay. So this question mark here we're going to call x, or the missing side will be x. And we'll have x over that big piece that it was divided into is going to equal our little piece over, and now this is the big part of it, is 10. The little piece and the big piece together equals 12, but we've subtracted to figure out what this part is. Okay? We'll cross multiply, and that'll give us 10x equals 2 times 15 or 30. Okay, we want the x by itself to solve for x, so we're going to divide by 10, and we'll get x equals 30 divided by 10, or 3. Okay, so this little piece over there equals 3. Okay, let's look at example number 7. Now in example number 7, you can see that once again, we've got this whole piece here, okay? So let's go ahead and look at what we have. The small on one side over the large on one side of our divided pieces equals the small of the other side over the large of the other side. Because since they're parallel, okay, then they are going to be proportional, okay? Now, it looks like these parallel markings didn't end up on your copies. Those lines are parallel to each other, okay? So when we're doing this problem, we need to notice that 64 is the size that is the entire side over here, okay? And 72 is our entire side, okay? But we need a piece and a piece, okay? So we need to know what's this part, okay? And we need to know what this part is, all right? So here's our big, right? And then our little and our big and our little, okay? So we're missing these pieces. So this part right here is going to end up being 64 minus the smaller part, all right? So it's going to get a little bit more complicated. So this part here is 64 minus, and then negative 4 plus 4x. That's this little side, okay? And over here, we're going to have 72 minus the 27, okay? That's going to be this little guy, all right? So what we want to do now is we want to put both of the matching sides. So we'll go 64, and then when we subtract here, we'll add, and these signs will change, okay? So we'll have 64 plus 4, okay, minus 4x, and that'll all be over negative 4 plus 4x, 4x on bottom, right? So this side over this side is going to be equal to this guy over this guy. So 72 minus 27 over 27. Okay, so now let's go ahead and do some simplifying. Now remember, when those lines are parallel, it's going to cut these two sides proportionally. All right, so one piece over the other piece will equal one piece over the other piece. Okay, so when we simplify this, we'll end up with 68 minus 4x over, and let's just swap sides here, 4x minus 4 equals, now when we do the arithmetic, I want you guys to go ahead and pull up your calculators and just plug that in. So 72 minus 27, and that will equal 45. Okay, so we'll have 45 on the other side over 27. And we'll just cross multiply. Now I kind of missed my guy over here, but we'll cross multiply and we'll end up with 27, and then we'll multiply 68 minus 4x. Okay, this number times our simplified version here, okay, equals 45 times, and it's this number on the bottom, 4x minus 4. Okay, so I want you guys to go ahead and solve that out. Okay, you can see the notes that I've attached for the complete solution, but this gives you a sense of how to approach it. All right, let's look at example number 8. Same thing. We're going to end up having to find out our missing chunk here. That'll be 28 minus 8, and it'll give us 20 for this missing piece up here. Now, since these lines are parallel, okay, our small piece here over the bigger piece are going to equal on either side because they're proportional. All right, so 10 over 3x minus 5 will equal 8 over 20. And once again, we'll cross multiply and solve for x. So this will give us 10 times 20, which is 200, equals 8 times 3x minus 5. All right. Again, we will distribute this to both terms. 8 times 3 is going to give us 24x, 8 times 3x, and then minus 8 times 5, which is 40. Okay, we want to get that x by itself, so we're going to add 40 to both sides. We'll get 240 equals 24x. Okay, and then we'll divide both sides by 24, and x will equal 10. Okay, so that's how we work these. They're pretty easy, you guys, and we'll see you on the next video. Thank you.